Dear colleagues, I propose to continue our section. I remind you that we have approximately 15 minutes for every paper, at least 10 minutes for the speech and 5 minutes for the questions. So let's start. The first paper is improving speaking verification model for low resources languages.
Yes. Hello, everybody. Can you see my screen?
Yeah.
Okay, once more, hello, everybody. My name is Maxim Kizitsky. I'm from Kharkiv National University of Radioelectronics, and I would like to present you a paper called Improving Speaker Verification Models for Low Resources Languages. So the motivation of our work is that the development of speaker recognition technologies have a variety of motivation, including improving the accuracy and efficiency of speech-based human-computer interaction, and developing personalized services such as voice assistants and smart home systems that are quite popular nowadays. Aims and goals of this work. The aim of this work is to develop an approach to perform highly accurate, comparable with performance of state-of-the-art models for resource-rich languages, speaker verification for low-resource languages like Ukrainian. So the goals of this work is to study the efficiency of transferring skills of speaker verification from other languages, develop a robust speaker verification system, compare the efficiency of different approaches and algorithms. As a base dataset, we have chosen a common voice dataset. It is a crowdsourced dataset that contains a lot of recordings from different people in more than 120 languages, including Ukrainian. In the Ukrainian part of this dataset, there are 73 hours of recordings of 120 speakers in train split, and 14 hours of recordings of 639 speakers in test split. So as we can see, there are a lot more speakers in test split than in the train split. Additionally, for some experiments, we use other languages. The duration of these parts of datasets and number of speakers you can see on the slide. Also, we didn't use raw audio data. We transformed it to MEL spectrograms. The example of MEL spectrogram you can see on the slide. So next we have chosen some key metrics. First of all, it's equal error rate. It's a common metric in task of speaker verification and some other tasks that are linked with metric learning. Next, it's precision at top K. That means how many samples of the same class as original data point are present in top 3 recordings by similarity. Next is mean and standard deviation of positive similarity. That positive similarity represents similarity within the class, and mean and standard deviation of negative similarity represents the similarity between original data points and data points that belong to other class than the original one. We performed 5 experiments. First one was aimed to determine the best architecture to continue the experiments. Second was to determine best loss function. In third experiment, we determined the possibility of transferring skills from other languages. In fourth experiment, we identify the possibility of applying DOLC architecture. We'll talk about it a bit later in the task of speaker verification. And in the fifth experiment, we determine how the usage of data augmentation affects the training process. So we have chosen several base models because we transform the raw audio to MEL spectrograms, so we can treat it like an image data. So we have chosen ConvNext. That is one of the most popular and most effective architecture in other computer vision tasks. So we suppose that it can effectively adapt to audio domain. Because MEL spectrograms are different from traditional images, we have used randomly initialized weights because we suppose that there is no effect from using pre-trained ones. And second is a DOLG architecture. This architecture is widely used in image retrieval tasks and face recognition tasks because it can take into consideration both local features and global features. And it shows superior results in many applications, including Kaggle competitions. So let's proceed to results of our experiment. On this slide, you can see how the loss functions changes during the first experiment. During this experiment, we compared ConvNext small and ConvNext tiny. We compared only these versions of neural networks because we haven't got enough computational resources to perform even base or large model. So as we can see from this plot, the loss on validation set changes approximately the same for both networks. So we have chosen a tiny version because it has fewer parameters, so we can perform experiments faster and perform more experiments. In second experiment, we have tested different loss functions, including triplet loss, arc phase loss, subcenter arc phase loss, and their combinations. As we can see from these plots, the performance of models with that only trained with arc phase or subcenter arc phase loss is approximately the same, but with models that are trained with triplet loss, they reach the plateau faster and stop training after approximately 6 epochs. So we, in the second experiment, we have chosen subcenter phase to continue our experiments. In the third experiment, we try and to compare base models trained only on Ukrainian dataset with models trained on multilingual dataset. The validation was performed also for both multilingual models and Ukrainian models on Ukrainian dataset. Because multilingual dataset is a lot larger than only Ukrainian one, we can perform training only for 4 epochs, rather than 12 with Ukrainian dataset. But as we can see, this model trained on multilingual dataset show better initial loss and precision at top 3, but if their data set is unbalanced, it means that for each speaker is for speakers from other languages other than Ukrainian, there is a lot more samples. We can see that performance starts to drop. It may indicate the overfitting, so we suggest if you are trying to train on multilingual dataset, try to balance it with number of samples for the original language. On this slide, you can see the results of applying DOLG architecture and data augmentation. So this is fourth and fifth experiment. DOLG architecture shows superior results to other experiment and pretty much reach their state-of-the-art result for language speaker verification for languages like English. On this slide, you can see the table with final results for all experiments. As we can see, speaker verification with DOLG and augmentation reach equal error rate of 0.05, which indicates the quality of approximately the 90%, which is equal to state-of-the-art results for other languages. So this approach can be applicable for Ukrainian languages and comparable with results with state-of-the-art results for other languages like English, French, etc. Next, we perform further testing. We perform speaker dualization. It means that we split the dialogue by people who are speaking using our model. We perform with the help of our model, we embed the chunks of the text and on slide you can see that this TS and E projections, and we perform clustering. As we can see, there are two clear cluster and about the region which represents the parts where both speaker speaks. And here you can see the example of subtitles. So in the discussion section, you can see all the key points I have discussed earlier. So we, in the first experiment, we have chosen coordinates tiny because we can perform experiments faster. In second experiment, we have chosen arc phase loss function. In second experiment, we have chosen to train on multilingual dataset, but balancing it with Ukrainian one. In fourth experiment, DOLG shows superior result, and in fifth experiment, data augmentation shows leads to more robustness to new data. So in conclusion, the study demonstrates the efficiency of deep learning models in task of speaker verification for low resources languages, and also it provides the insights into the best performing network architecture and loss function to this problem, and shows the potential for transferring skills from other languages to low resources languages. The perspective of further study includes comparing the large amount of convolutional network architecture, especially with large number of parameters, different loss functions and their combination. And also it's quite important to study transferring skills from other languages and perform multilingual speaker verification. That's all. Thank you for your attention. Maybe there are any questions.
Thank you. Are there any questions for the speaker? Okay, I have some questions for you. First of all, could you show or maybe describe in more detailed way the set of input data?
Okay. Here is the slide. First of all, it's all this data taken from Common Voice dataset. It's include Ukrainian language. You can see the duration and number of speakers at first. And we also have chosen other languages. It was Belarusian languages and Polish, because we thought that it sounds quite similar to Ukrainian. So we suppose that skills from speaker verification in these languages can be transferred to Ukrainian. The validation was performed only on Ukrainian languages. And all the audios were split by 3 seconds because some audios are longer, some shorter. So to train a network on approximately the same data, we split it on intersecting chunks of 3 seconds and transform it to MEL spectrogram.
Okay, thank you. And I have other questions for you. Which criteria did you use for evaluation of the proposed architecture? You mentioned 2 types of architecture in the slide below, and how to evaluate?
Okay, on this slide you can see the main metric.
No, not key metrics. I mean architectures.
So I evaluated.
Next slide.
Yeah, this
slide.
Yeah,
this slide. Yeah.
Yeah. First of all, I have chosen ConvNext architecture because, first of all, it shows great accuracy on computer vision tasks like ImageNet, etc. So we assume that it can learn new patterns easily, so it can be applied to new domain like processing null spectrograms in speaker verification. It's about convex architecture. In other hand, DOLG architecture is widely used in face recognition, which task like similar task to speaker verification, but in computer vision domain. Superior results show in this task, and additionally, it shows great results. So it's a great accuracy and great equal error rate in task of image retrieval. So these tasks are both metric learning tasks as speaker verification tasks. So we assume that it also can perform nice in our task.
Okay, thank you for your answers. And thank you for your speech.
Thank you.
So I propose going to the next slide. Reference, not slide, I mean paper. A reference model for collaborative business intelligent virtual assistant.
Okay. I hope it works.
Yeah.
Okay, my name is Olga Cherednichenko, and today I'd like to present the results of our research. And today I'm representative for the team of Fahad Mohammad, Jérôme Darmon, and Cécile Favre. We are working in the same laboratory in University Lyon 2. And our study is funded by the French National Research Agency under the project BI for the People. And today I'd like to shortly introduce the idea and background why we started this research, and then say about what is it collaborative BI concept, and which research question we answer it, and then describe our results as a reference model of collaborative BI virtual assistant, and finally discuss and make the conclusions. So collaborative business analysis is a methodology that encourages knowledge sharing and collaboration between the different groups involved in business analysis. And the main idea is to collect people in one virtual or real space and encourage them leave their comments or opinions for general purpose. Moreover, using another collaborator's results or comments makes general business intelligence collaborative. And there are two main issues that we need to resolve. It's collaborative space and how we can reuse the experience. So the main idea and the main focus of our research is about how we can organize this collaborative space where the users can do their research, data exploration, and decision-making, and how we can reuse the experience they obtained during this process. The main goal of our project is to bring the power of all-up interactive analysis to the largest possible audience by implementing the data warehousing process in software as a service mode. To achieve this goal, the business intelligence service must implement privacy by design, by autonomous, extremely simple, user-friendly, intelligible, and allow collaborative analysis. So the main focus for today's research is about how to do the collaborative analysis. And we mostly discuss about the framework, how we can organize this collaborative BI in terms of a conversational assistant concept. The main goal of our study is investigate and improve the collaborative BI tools based on virtual assistants. And there are research questions. What is the main scenario for a collaborative tool on a virtual platform? What type of collaborative agent is the most relevant as a CBI assistant tool? What artificial intelligence models and natural language understanding should feature is CBI virtual assistant? As analysis shows, a lot of chatbots and conversational agents are used to support different processes of collaboration and decision making. With identifies that a chatbot is a computer program that can simulate human conversations through text or voice interaction with users. And there are a lot of different examples, successful examples, so we can underline like IBM Watson Assistant or Dialogflow platform, Rasa, the BotPress platform, and so on. And we need to say that the main points of the concept of collaborative business intelligence can be like collaboration, data sharing, visualization, agility, and continuous improvement. So we understand that chatbots become really popular in terms of collaborative tools because of their efficiency. They can automate routine tasks and processes because of their personalization, because chatbot can be customized to meet the specific needs of individual users, their scalability and availability. We research the state of the art and can underline that collaborative business intelligence system can have different architecture. It can be like social business intelligence, mobile business intelligence, cloud-based, self-service, or embedded. And also they implemented different tools for facilitating, like chatbots, conversational agents, or dialogue systems. According to our analysis, we can say that the most popular architecture of neural networks that can be used for conversational agents are like recurrent neural network, long short-term memory, and the sequence-to-sequence models, and so on. That is why we think that this combination will be useful to realize the conversational virtual assistant in our purposes. But to do this task, we need to realize how the main process do, and we underline the next main steps of data exploration process. Firstly, we need to define the business problems and identify the stage of collecting data, preparing data, exploring, communicating insights, and action planning. And our virtual assistant should help users and support for each of these stages of data exploration. So, as analysis shows, the typical architecture of conversational agent can be based on rule-based architecture or finite state machine, or natural language understanding model or hybrid architecture. And we think that in general meaning, it consists of natural language understanding module, dialogue management module, and natural language generation as well. The typical scenario, how user can interact with collaborative BI module is represented on this slide. And as you can see, the user asks some request, and the system should process it and give the answer, and then the user can precise their request, and this process should be continued, and as a result, the user should obtain the visualization of data or answer the questions they ask to the data which he or she explore. So we present our framework like a module for a business intelligence platform. And it means that we provide the collaborative business intelligence virtual assistant that consists of three main parts, like conversational agent, data exploration agent, and recommendation agent. They should communicate each other in order to provide all necessary information for users and support there for every stages of data exploration. Conversational agent provides the part to support the dialogue and human manner. And the main idea of the conversational agent, they follow the scenario and collaborate with users and ask for their comments and provide some recommendations for users. Data exploration agents should grab some command from the text of conversation and transfer this expression part of conversation to the command to process the data, for example, filtering data or structuring in some special manner. And also recommendation part, the recommendation agent should collect different requests from users, the results of answers, their reaction and behavior, and provide recommendations for new users who are not experienced in data exploration, how to deal with the BI platform. So this is the result of our work. I'd like to say that it is really very beginning of our study in this context of collaborative tools. And according to our research questions, I can say that the main scenario for collaborative tool is virtual assistant based on text communicating, involves presenting the finding in a clear and concise manner using visualizations that can be easily understood by users. It includes dialogue between the user and chatbot in order to explore the data, choose the acts, and create the visualization. The chatbot has provided recommendation and assist with data processing acts. Also, we underline three-component conversational agent, or three agent models that which consist of three units as conversation part, data exploration unit, and recommendation unit. They will interact each other and can be implemented as a multi-agent model in order to support collaborative unit on the business for the people platform. The artificial models and natural language understanding model should be identified in the future work based on experimental research due to wide set of available options. I think that is why I'd like to present for today. Thank you for your attention.
Thank you. Are there any questions for the speaker? Okay, I have one question. You mentioned the agent in terms of intelligent agent. Could you tell me what kind of system do you presuppose in your research?
Actually, the main platform is not multi-agent system, and I think it would be not like a classical multi-agent, and there are a little bit tricky word agent because we use it for conversational agent, for intelligence agent, and so on. So in our framework, we suppose it that agent, it's like a module unit, but it can interact each other. So it has some features like an intelligence agent.
Okay, thank you. So I propose go to the next speech. Thank you for your presentation, Olga. Thank you. And for now, we are waiting for the speech, representation of knowledge by temporal cases in humanitarian response. Do we have authors of this paper?
I think the next one is knowledge base of intelligent information system for prediction of phase stability of solid solution. Yeah.
No, it could be last one because we don't have the previous speaker. For now, oh no, we have representation of knowledge by temporal cases. Yeah, we have the speaker, okay. We see the screen, but we didn't hear you. I don't have sound actually.
No sound, I think, for everybody.
The sound is absent.
Hello.
Oh yeah, we hear you.
Can you hear me? Yeah.
Yes, yes, for now we hear you.
Can you see the presentation?
Yes.
Yeah.
You can start.
Dear colleagues, your attention is presented to a report on the topic representation of knowledge by temporal cases in humanitarian response. The author Victoria Demina, Tatiana Belova, Irina Pobezhenko, Olga Chala, and Tatiana Demina. Humanitarian aid is a type of assistance with remedies for living which are provided free of charge of the population of areas affected by humanitarian disaster. Humanitarian aid is characterized by its urgent nature and the necessary of continuous monitoring of the population needs. The main directions of humanitarian response are food security and livelihoods, healthcare, housing and non-food product, water, sanitation, and hygiene. Humanitarian responses is a complex and multi-stage process, whereas the most important criterion in the time of providing the necessary assistance. The need for humanitarian response may take place over a long period of time. In addition, there are many unplugged factors in the implementation of humanitarian project. The situation in the disaster zone can change rapidly, which leads to new requirements for the provision of assistance. The process of designing making of humanitarian response, the following should be taken into account. The best possible solution is selected because there is no guaranteed solution to the problem. Accumulated experience of solving similar situation is used as the main source for decision making. Obtained solution can be used in the future with the possibility of the adaptation to new situations. The model of knowledge representation of the subject area determines and the effectually of designing making. The specificity of humanitarian response requires simple and adaptive models that are easy to apply in rapidly changing situation. Case-based reasoning (CBR) can be used to solve this cluster of problems. It has proved itself well in situation where the principle of regularity is fulfilled and the tasks that have to be solved are reparated. The knowledge accumulated by the system can be used to process new scenarios. The CBR process included 4 main stages that form the CBR cycle. Retrieve the most appropriate case or cases for the current situation from the case base. Reuse the retrieved case to attempt to solve the current problem. Receive the necessary for the resulting solution following the current problem. Retain the newly made discussion as part of the new case. The disadvantages on the CBR method include does not solve fundamentally new problems, does not take into account previous deception, difficulty in choosing a criterion for extracting cases. The question areas of adapting the case based to case where it is not possible to extract a similar template. In this case, it is possible to combine CBL with other machine learning method, partially in the stage of cases adaptation. To work in a critical situation with a rapidly changing reality, the case must include not only the value of the parameters and the current time, but also their values for a central period of time before that history. Temporal case is divided as situation S, supplemented by script and expert advice. For successful implementation of CBR, it is necessary of ensure the correct instruction of cases for the certain temporal cases in a set of retrieved case. As a result, the expert received a set of analogies ordered in accordance and the degree of similarity of descriptions. Let's consider building a temporal case according to the history of parameter change. At the first stage, we will use the compressed history of change in the parameter of the observed object into a series of events. At the output, we get the primary temporal case. If an existing case is specified when after that is necessary to match cases whose the combined temporal case is obtained. Note that both the merging case and when refining case, it is assumed that the state of the controlled object in the merged cases is identical at the corresponding points in time. In practical, this condition may be analysis be met. Therefore, it makes sense to implement an algorithm that average the value of the parameters, then combining events or make the transition from the extract value of the parameter to the allowable range of its value. The CBR cycle based on temporal cases is presented on this slide. The difference from the classic CBR cycle is the construction of the temporal model of the situation and additional block of multifactorial analysis. Let's consider the use of the development method on the example for the humanitarian response to the population water needs. The humanitarian response plans of Ukraine 2023 and the relevant legislative framework were used for the initial filling of the case base. Table shows the change over time of some criteria of the basis of with the need for humanitarian responses is determined. Based on the analysis of the presentation data, it is possible to trace not only special factors, but also time segment, how these parameters was changed after the execution of the selected scenario. Figure show an example of the time diagram that allow evaluating the effectiveness of using scenarios. Four parameters were selected for analysis for scenarios were used in a result of observations. You can see the conflicting scenarios, for example, in Tact 5 of the delivery of individual cleaning product and water delivery scenarios. On the Tact 7, we see that after the complete restoration of centralized water sampling, all parameters are stabilized, where is no need for humanitarian response. Whose, thanks to the use of temporal cases on a real-time scale, it is possible to find effective solution that take into account both the current situation and the history change in the state of the object and pre-made discussion with strike time limits. The proposed temporal CBR is implemented by the structure on the corresponding model of the intelligence decision-making system. Knowledge base of temporal case contains a description of situation in the following form: number, name, set of parameters, value, structure of events, respondents scenario, and expert recommendations. The monitoring block allows you to monitor process parameters stored in distributed databases. A critical situation means a case when one or more parameters cross a criminal limit. In the event of a critical situation, a corresponding model is created in the building block of the temporal model of the situation. The analysis and extraction block compare the model with who's described in the case base and form a subset of the extracted cases. Next, the case is specified in the training block. Several methods can be used for this, finding the arithmetic average of parameters, the shortest path, merging cases, comparing time limits. The process of learning on temporal cases allows developing classical CBRL by taking into account and analyzing the discussions that were obtained earlier, time logic with polynomial estimation of algorithm complexity of used for logical derivation. The advantages of the CBR method can be considered the case of acquiring knowledge, the possibility of explaining solution, obtaining new solution through training and modification of existing cases, the integration of spatial and temporal facts making is possible to create adequate models of knowledge about the process of humanitarian response, which are able to adapt to a rapid change in the situation with minimal costs. The proposed structure of the case generation model can be used by both humanitarian and organization and government agencies. Authors' contact are presented on the slide. Thanks for attention.
Thank you for your presentation. Does anyone has some questions for the speaker? Okay, I have one question for you. Could you tell me which criterion, or maybe we are talking about methods, which did you use in your presentation for extracting or retrieving similar cases? You understand?
Yes, I understand. I would like to touch the topic temporal cases. Temporal cases allow talking about according not only the parameters of the current situation, but also the history of previous states of the control object. This makes it possible in consider the subject array in dynamic.
Thank you. Don't hesitate to ask some questions to the speaker. So we don't have any questions for you. Thank you, Victoria, for your presentation. And now we are going to last speech in this part of the section. And this speech is about knowledge base of intelligent information system for prediction of phase stability of solid solutions.
Hello, do you see my screen?
Yes, we see screen and we hear you. You can.
Okay. I think that Oleg Bisikalo starts the presentation and I will continue.
Hello, everybody.
Hello.
Ну как мне нужно было что-то одним сказать, и это самое.
Hear
I
me.
hear you.
Ну, все равно я с ними разговаривала, потом голос будет другой.
Authors, you start your
Ah.
presentation.
Yes, yes. Nah.
Mhm.
Good afternoon, everybody. My name is Oleg Bisikala. I am head of Department of Automation and Intelligent Information Technologies of the Vinnytsia National Technical University. I am glad to see and hear all of you. The topic of our article is knowledge base of intelligent information system for prediction of phase stability of solid solution. And I can I will report the presentation with my PhD student, and so after Alexei Kudryk. Please, next slide. Okay. Currently, compounds of rare earth elements with tetrahedral oxyanions, phosphates, vanadiates, silicates, oxygenates are being intensively studied. This is due to their use in the manufacture of materials for Photoshops, lasers, LED, as displays, tomographs. For disposal of various radioactive wastes, including nuclear reactions and dismantled nuclear weapons, as the service life of the aluminophosphate or borosilicates glass used for these purposes in only up to 30-40 years. 30-40 years, and the purpose of this article is to develop a knowledge base for an intelligent information system for predicting the phase stability of solid solution. Under the knowledge base, we mean a set of facts and inference rules that allows you to draw logical conclusions and purposefully process the necessary information. The next slides will be commented by my co-author and PhD student of our university, Alexei Kudryk. Please, Alexei.
Yeah, hello again. The expert system is a software tool that uses expert knowledge to provide a highly efficient solution to information problems in a narrow subject area. The basis of expert systems is a knowledge base about the subject area, which accumulates in the process of construction and operation of expert systems. Accumulation and organization of knowledge is the most important property of all expert systems. So before the system can work, it must be filled with data. Data for this system were taken from various scientific sources, both modern and fundamental, which were published in 1930 till 1970. The data set is very large because for each lanthanide it's necessary to enter a number of parameters that are necessary for prediction. You may also enter a parameter for each type of system. Let's consider the model of production type knowledge base for predicting. Let's present the model being developed as knowledge base, which consisting of relations, production rules, predicates, functions, and operators. The following are the formal relationships that allow us to consider the informational component of intelligent information system for stability studied solutions in terms of the relational data model. On this slide, you can see the scheme of formal relations. We can notice the main relationships like element, a relation to characterize element, charge element, a relation of characterizing element charges, coordination element relation for characterizing charge coordination numbers, and for example, storage system relation for characterize the given system which was calculated. I would like to highlight one function for entering the data into the system. In the process of creating an element, the possibility of adding general parameters to the element is taken into account, element parameters function. So for each element, it's necessary to ensure that indicators are obtained from the database. Therefore, if the parameter pi of some is element from n is not presented in the system, the universal value def is chosen. Otherwise, it's necessary to enter the value p. Let's formally define product. We can see this. Also some functions for prediction. In the prediction process, data analysis has taken place. It's a pred analysis function. For each system, it's necessary to ensure that the indicators of each element are obtained from the database and analyze where it's possible to make a prediction. Therefore, its parameter AI of some is element from AN is not presented in the system. The universal value ADEF is chosen. Otherwise, it's necessary the value AI. Let's formally define analysis product that's on the screen. During data analysis, it's also checked whether such system with the same set of input data have already been calculated. It's a pred-analysis data function. If it has been calculated, then we output the found data. Analysis is the compression of data from the database, namely in the tables, storage system, and storage result is carried out. So if the SD data of some DES element from SR is available in the system, we pass the SD value. Otherwise, as found. Formally also define the analysis data product. Also some operator. For data processing, after setting the type of prediction algorithm, the prediction function was created. A certain set of fields must be passed to the function element ID, STRS ID, element ID lanthanide, epsilon, algorithm type. Formally, the prediction operator has the form. To display the data on the user interface, the return result function was created. It's necessary to transfer a certain set of fields to the function, like stdrid. It's a unique UID code of data about the calculated system. Formally, it's data display operator on the user interface. And the operator print. In order to visually easily show how an element was created and which elements were entered into the system, a function was created to print the table of print elements. Actually, each element is formed from certain set of fields: element ID, element song, element name, code, count, formally element print operator. So the scientific and technical results. In this work, for the first time, a knowledge-based model was created for predicting the phase stability solutions, which, unlike the existing one, takes into the unique limit of substitutions of each lantanide with the help of set prediction rules, predicates, functions, and operators, which allows to increase and accuracy calculation of energy, of mixing, and to calculate the exact, not the general critical decomposition temperature of the corresponding lantanide. So thank you for your attention. If you have any questions, you can ask us.
Thank you. Are there any questions for the speaker?
Okay.
I have one question for you. Which mathematical apparatus do you use for searching appropriate cases in knowledge base? Maybe you mentioned.
I think that here I only show you the knowledge base, but we created the mathematical model which calculates the system. You input the data, and output you have a prediction, the result. Yeah, here we show the knowledge base.
Okay. Do we have any questions for Alexey? Okay. Thank you, Alexey, for your presentation. As I understand,
Thank you.
Have any questions? So, dear colleagues, we have a little break for coffee time, and we are waiting for you in 15 minutes on the next part of our section. Thank you all for your presentations.